equals 6. The function fx equals to that, but we're missing two numbers, which is a and b values. Has a factor x minus 3 when fx is divided by x minus 2. Okay, if I divide by fx minus 2, the remainder is 15. If you calculate, okay, first we know x minus 3 is a factor, and we know when we divide by x minus 2, the remainder will be 15. Okay, so fx divided by x minus 3, that will equals to some quotient, but plus 0 remainder. Okay, I have 0 remainder. So when we divide that, I'll have 0 remainder. Because it's a factor, factor means there's no remainder. Actually, I should write it smaller because that's quite a lot of working for this question. So px divided by x minus 3, I have 0 remainder. And then if I use that to divide by x minus 2, I will have 15 is the remainder. Okay, I divide by different thing. I have 0 remainder and I have 15 of the remainder. Okay, so what we can know from those two things? Okay, from the first one, okay, if I divide that, I have 0 remainder, which means if I substitute, I make x minus 3 equals to 0. And if I substitute x equals to 3, it should give me the remainder, but actually I have remainder 0. Which will tell us f3 is 0. And then I make x minus 2 equals to 0. Then x equals to 2. What that actually tells us? It tells us f2 will give me the remainder for x minus 2. Divide x minus 2. Then I got remainder 15. So f2 will be 15. Okay, f2 will be 15. Okay, now we know two equations. Let's set up this simultaneously. So f3 equals to 0. So it's 2 times 3 cubed plus 9a. So 3 squared is 9a. Minus 3b plus 3. That gives me 0. Okay. Let's see what's that. Well, let's do 9a minus 3b will equals to minus 3 minus, okay, that's 27 times 2 is 54. 9 times 3 is 27. 27 times 2 is 54. So it's that. So that's minus 57. We have a minus 57. And I can divide 3. So it's 3a minus b equals to minus 19, right? Minus 19. Okay, that's my equation number 1. And then from f2 equals to 15, I can have 2 times 2 cubed plus 4a minus 2b plus 3 equals to 15. So that's 4a minus 2b equals to 15 subtract 3 subtract 16, which is minus 4. Okay, 15 minus 3 is 12. 12 minus 16 is minus 4. So I have minus 4 here. And I can divide that by 2. So it's 2a minus b equals to minus 2. So that's equation number 2. Okay, we have equation number 1 and equation number 2. So what I can do is subtract them. Subtract them. Because I have minus b and minus b, if you subtract them, the b just cancelled. So 3a minus 2a is a. Minus b minus b is 0. That equals to minus 19 minus negative 2 is plus 2. You have minus 17. And what is b? B will be, okay, for this b, is b equals to 2a plus 2. Okay, from number 2, you can see b equals to 2a plus 2. Then b equals to minus 17 times 2 plus 2. b equals to, okay, 34, 32. Okay, b equals to minus 32. Okay, the next thing, that's only answered one question. Okay, that only answered one question, which is like a and b values. Okay, which is the a and b values. But you have another thing asking you, what is the other 2 factor? Now you already have 1 factor. You want to work on another 2 factors. So let's write out fx first. So what is fx? Fx is 2x cubed minus 17x squared. Okay, minus b. So b is negative 32. So it's plus 32x and then plus 3. And then let's put numbers in. I have coefficient 2, coefficient negative 17, coefficient 32, and constant 3. Okay, what number I should put here? I should put 3 or I should put 2? Okay, I divide x minus 3 and also divide by x minus 2. But I want to find the other 2 factors. Which one I should put in? Which one will give me remainder 0? 3. 3. Why I put 3? Because I want to find factor. X minus 2 is not a factor. It's not worth me to put it in. Because if put in, I will find remainder like 15. It's not helpful. I can't find factor because I already know x minus 2 cannot be a factor. So why I put x minus 2 in? It's not working. So I'll put 3 in. I'll put 3 in. So let's put 3 here. Okay, this also can help me to test whether I have the correct answer or not. What are you aiming for? You're aiming for the last box should be a 0. If the last box is not a 0, which means I calculate a and b values wrong. Okay, I give a wrong equation. 3 is x minus 3 is not a factor for that. So now let's see. I will put 2 here. 6 minus plus negative 17 is minus 11. Okay, you have minus 33 plus 32. You have minus 1. 3 times minus 1 plus the 3, you have a 0 here. Which is correct? Okay, which is correct? Let's see if we put 2 in, what will happen? Why I'm not putting 2 in? So if I put 2 here, okay, I still have 2 here. 2 times 2 is 4. 4 minus 17 is minus 13. Minus 13 times 2 is minus 26. Okay, you have a minus 26 here. You will have 4 minus 13 minus 26 plus 32. You have a 6 here. Okay, you have 6 here, and then 2 times 6 is 12. 12 plus 3 is a 15. So I have a remainder of 15 there, which means it's correct. Okay, the last box is the remainder. And that's the coefficient for x squared, because here is x cubed. Then you reduce one is x squared, x and the constant. So by the second row, what I can write is fx will equals to x minus 3 times 2x squared minus 11x minus 1. But I can't write that for the last row because the last row needs to plus the 15 in the end, and it's not a factor. Okay, it's not a factor. You can't factorize from that equation. So now I have a factor x minus 3, and I have a quadratic there. And I need to further factorize that. Okay, I need to further factorize this. this quadratic. So I need to check about the discriminant. The discriminant equals to 11 squared minus 4 times 2 times negative 1. Okay, times negative 1, which means it's plus. So the discriminant must be greater than 0. So I can factorize that. Okay, I can factorize that. But before I want to factorize this, let's think. 1 and 2 cannot make 11. Okay, it doesn't matter how you factorize, you can't have 11. So you cannot use the cross multiplication, and you still get the x term there. So which means I must do the completing square to factorize it. Otherwise, I can't factorize by any other method. It can be factorized, but cannot be factorized by the easy way. So 2x squared minus 11x minus 1. I want to factorize that. Okay, I cannot factorize it when there's a coefficient in front of x squared. Okay, I cannot factorize that. So I will take 2 out. I will take 2 out, and I will say x squared minus 11 over 2x. But I'll keep the constant outside. There's nothing to do with that constant. To complete, you can put the constant in, okay? Or like I can put it out, because I will times the constant out anyway in the end. So I will directly leave it outside. So 2x squared minus 11 over 2x, okay, plus half of b squared minus half of b squared. And then do not forget your constant, which is outside the bracket. Okay, those three can complete square, and you have a constant in the end. Okay, so the important thing is, even though you complete square for those three terms, but there's a bracket, okay, this big bracket is still there. They're not going out of this bracket. So here you will have x minus 11 over 4 squared, okay, for those three terms. It got a bracket, but this bracket is not the outside bracket. It's like a new bracket just create because I completing the square for those three terms. So I will minus, what was that? 1 to 1 over 16. Okay, 1 to 1 over 16. Okay, so you have the minus 1 again there. Well, let's put this minus 1 inside. Let's put this minus 1 inside. Let's make that a half. Let's make that a half, because I want to combine them first. Okay, so you minus a half. That's a green bracket. Minus a half is minus 8 on 16. Okay, 8 on 16. So 2 times x minus 11 over 4 squared minus 1 to 9 over 16, right? It's square root 1 to 9 over 4 and then squared. Okay, in the bracket you have a squared minus b squared. Okay, you have a squared minus b squared. And that's 2 bracket x minus 11 plus 1 to 9 over 4 and x minus 11 over 4 minus square root 1 to 9 over 4. So I can put this 2 in any bracket. Okay, I can put this constant 2. You can leave it outside, or you can times inside the first one. Maybe become 2x minus 11 over 2 plus square root 1 to 9 over 2. Or you can keep it outside. So the other 2 factor will be this. Will be this one and this one. Okay, the other 2 factors. Okay, it's a pretty long question, but do you have any problem with that? you can put the 2 in, say that's 2x minus 11 over 2 plus square root 129 over 2, but you only put the 2 in one bracket. Do not influence the second one, okay? Do not influence the second one. The second one will not be times by 2. You only have 1, 2. This 2 can only combine with one bracket, not both of them. Okay, so you have this. Do you have any questions about this? Okay. Okay, 3 stages for this question. First, using the factor theorem and remainder theorem to work out A value and B value. Second, you know one factor already. How we can find the quotient when fx divided by that factor? You work out the quotient for the quadratic. Okay, that's stage number 2. We use the box method. Stage number 3, we use completing square to factorize the quadratic again and to find the other 2 factors. Okay, so it's a 3-stage question. Any questions? Okay. If we don't have any question, can we look at the next page, please? Okay, have a read that question. That's a really short one. So it just asks you to factorize. Okay, from now on, the following 2 pages is all factorized. Okay, so how we can factorize different equations. So I want to factorize this. Anyone can tell me how we can factorize? Like, there's no hint for you now. Okay, just a equation here and ask you to factorize. How, like, what you will start with? Shake your head, no? Oh. Okay, how you will start? Let's suppose x minus a is a factor of this equation. Okay, let's suppose x minus a is a factor of this equation. Let's say this equation is px. Okay, let's say this equation is px. Expression is px. And if that is a factor, okay, say if x minus a is a factor, then pa must be 0, right? Pa must be 0. So the first thing you want to do is to find a number can give you the equation to be 0. For example, p1 is 0. You need to check. Okay, it's a trial and error question. So you need to try some values, maybe 1, 2, 3, negative 1, negative 2, negative 3, to see which number will give you PA equals to 0. You change the A values. But I would not recommend, that's like what most of the teacher will teach. They will say try a value, substitute into the equation to see which one to be 0. But think about this. After you find out, okay, that is 0, what's the next step you do? If you find PA is 0, then which means x minus a is a factor. After you work out this factor, what you will do next? What you will do is you use px to divide by x minus a to find the quotient, right? Is to find the quotient after you find one factor, and you find the quadratic, and then you factorize the quadratic. So you still need to use long division or the box method. How about we directly start from this box method? Okay, how about we directly start for a box method? So let's see. We set up a table. And then we have 1, -2, -5, and 6 as the coefficient. Why can't we just change the value here to see a remainder 0? This box is the remainder box. And what I want for the remainder, I want remainder 0, which means it is a factor. Okay, I need to try different values to make the remainder to be 0. So it's still a trial and error question. I will let you know in 1 second why it's better. rather than substitute values into Px. Okay, what values you will try? Tell me what values you will try. Will you try 10? Will you try 11? 1. Why is 1? Like if you can't see it, what you will try? Yep, that's correct. So the number worth you to try is the factor of the constant and is the factor of the highest, the leading term's coefficient. So for the 6, I will factorize that. What you have is plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Those are the numbers worth me to try. I won't try any other values except those 8 numbers. Because the coefficient is 1 here. So you just have plus minus 1 for the first term. So it's included in 6. So those 8 numbers is the number you will start to try. You won't try 5. Okay, 5 cannot be a factor for sure. Okay, can't try 5. You can't try 7. Those numbers you know is not true. So you will factorize the constant, and you factorize you see what is the factor of the constant and what is the factor of the coefficient of the leading term. Those numbers are the numbers you will start to try. Okay, let's try. You tell me 1, so let's try 1. So that will give me 1. 1 times 1 is 1. 1 plus negative 2 is negative 1. 1 times negative 1 is negative 1. Negative 1 plus negative 5 is negative 6. 1 times negative 6 is negative 6. Plus 6 give me 0. Okay, I got 0, which is good. So that is the x squared term, because here is the x cubed term. So you have x squared, x, and the constant. And that is the remainder. So what this equation equals to? Okay, the factor is x minus 1 or x plus 1. Plus or minus? Minus. Okay, you minus the number you try. It's not plus. So what you have been left is x squared minus x and minus 6. Okay, why this box method is good? Because you try numbers and directly factorize it already. Okay, you directly find out what's the other quadratic factor. Otherwise, think about if you try, okay, you work out, okay, 2 is the correct number. And then I will put 2 into this box method. I will do the step again. Why we can't directly start with the step? To find out directly what is the quadratic factor. So now I work out this. And I can further factorize that. Okay, it's x minus 3 and x plus 2. Because minus 6 can be negative 3 and positive 2. And you add them, that gives you a minus 1. Okay, that gives you a minus 1. Okay, we finished the factorize. Okay, it's fully factorized. It's a cubic. I have 3 linear factors, which is correct now. Okay, let's have a look at the next question. Okay, the next question is a little bit annoying. Why I say it's a little bit annoying? Because it's called the rational root theorem. Okay, the rational root theorem. Okay, so first of all, let's think about what are the numbers worth us to try. Okay, what are the numbers worth us to try? Okay, leading term coefficient of 2. So what are the numbers worth me to try? Plus minus 1 is always the number, and plus minus 2. Okay, for the 3 here, what I can have? Okay, plus minus 3. So plus minus 1, plus minus 2, plus minus 3. 6 numbers worth me to try. And the bad news is, if you try those 6 numbers, none of that will give you remainder 0. Okay, none of that will give you remainder 0. Maybe I'm better to give you 2 or 3 of them. I'll tell you what is the fail case, okay? We can't really always have the successful case. So let's see what is the fail case. So okay, so we will have 2 minus 1 minus 1 and minus 3. So let's try the number 1. Okay, I always start from the smaller number. The smaller is like the more possible it can be the answer. So I have 2 minus 1 is 1. That's 1. That's plus negative 4 and 0. 0 and minus 3. That one not working. Okay, let's try minus 1. 2 minus 2 minus 1 minus 3. 3 minus 1, 2. Minus 2 minus 3 minus 5. If you can keep going, you try all the 6 numbers. Okay, you see none of that is correct. Okay, none of that is correct. So if you put if you put plus 2 minus 2 plus 3 minus 3, they all failed. Okay, you have a try. Like you need to try. No one will tell you that going to fail. So none of that worked. And you don't have any valuable numbers to try. So what you can do now is called the rational root theorem. So when you try all the integer numbers and none of that working, you will start to think about some fraction numbers. Okay, some fractional numbers. So what are those numbers? Okay, so the number will be, okay, remember this clearly, okay? So it's not random fractions. It will be the fraction, the factor of the constant term. Okay, factor of the constant term over the factor of the leading term. Okay, is the factor of the constant term over the factor of the leading term, not including 1. Okay, not including 1. Not including 1 for this leading term, because you have denominator 1, it's still that number itself, it's not going to change. So now I'll have the factor will be 1 is the factor of the constant. Okay, you have 1 on the top. So what you're going to have on the bottom is the factor of the leading term, which is 2. Okay, it's 1 on 2. And you have plus minus 1 on 2. And another one will be plus minus 3 over 2. Okay, 3 over 2. Plus minus 1 on 2 and plus minus 3 over 2. You have create another 4 new possible numbers to try. Okay, after you try those 4 numbers, still not going to work, which means number 1, the question is wrong. Number 2, your calculation is wrong. Okay, it can't be other case. It must be an integer roots or rational roots. Okay, only be those 2 cases. If the integer not working, try the fractions. If still not working, go to see your mistake. Questions? No? Okay, so let's choose a number to try. I'll let you to choose which one you start. Negative 1/2. Okay. Okay, negative 1/2. Okay, I'll put the 2 down, and that's minus 1. Minus 1, minus 1, what do I have? Minus 2. And then times them, you have a plus 1. Correct? Plus 1. Plus 1 plus the minus 1 have 0. Have 0 here plus negative 3, you have minus 3. Oh, Bad luck, it's not working. Okay, anyone tell me another one? 3/2. Okay, put 2 down first. 3. Okay, 3 minus 1, which is 2. Have a 3 minus 1, have a 2. And you have 3 plus minus 3. Oh, finally we got the correct one. We have a remainder 0 here. Thank you. If you give me another wrong one, we may need to track another 2. So never stop. So what we have is x minus 3/2. Okay, x minus 3/2. And then we have 2x squared plus 2x plus 2. And what I'll have, I can take a 2 as common factor from this. So it's have 2x minus 3/2 have x squared plus x plus 1. And I can combine this 2 into the first bracket. Okay, I have 2x minus 3. It's not really necessary. You can keep down for whatever you have, but like I think it looks better if you times the 2 inside. And then I have x squared plus x plus 1. And can we factorize the quadratic? Can we factorize this quadratic? Can we? What do you do? When I ask you, can we factorize it, what do you check? Discriminant. Yeah, the triangle, okay? We need to check that. Okay, so what's that? It's b squared. It's 1 squared minus 4 times a times c. Greater or smaller than 0? Greater or smaller, everyone? Smaller. Smaller. Can we factorize? No, we can't. So, solution is that. Okay? It's not fully factorized, but I cannot factorize that further. So, stop here. Factorize 3x cubed plus 8x squared plus 2x minus 5. Okay, I'll tell you this belongs to rational root theorem. So it can't be the integer numbers. Okay, don't waste time to try it now. But when you do the test, if it's not telling you that's a rational root theorem, you need to try. Okay, you need to try. Otherwise, you don't know. Okay, so if you ask me whether I can see it, so I probably can see it when this number is not 1. Okay, the leading term is not 1. Because if the leading term is 1, I cannot create any fraction because the denominator will be 1. So when it's not 1, I will start to think about is that should be like a rational root theorem, but it's not 100% true because I have seen questions like this and you still have integer numbers. So the possibility is when you see that you start to think about the theorem, but you still need to try the integer numbers. Okay, so the coefficient for this one will be plus minus 1 and plus minus 3. The coefficient for that will be plus minus 1 and plus minus 5. Okay, so what's the possible fraction you have? Plus minus a third and plus minus 5/3. So those 4 numbers are the numbers you will try. You should get it for the previous question. It's okay. Okay, I'll draw more tables. If you choose the wrong one. Okay, I will try -5 on 3. If it's part 1 exam is not going to try positive, so where 3, 8, 2, -5, which one you try? -1 or 3? 5 or 3? Okay, let's try this one. Okay, 3 -5 plus 8 have +3 -5 plus 2, what's that? -3 +5 and that's 0. Okay, good. Yay, yay. Okay, so we have the correct one. Okay, and so we try this number. We need to subtract this one. Okay, x subtract that number. So that's x subtract -5 over 3 and 3x squared plus 3x minus 3. That will give me 3. I take a 3 out from here and x plus 5 over 3. And I have x squared plus x minus 1. And I'll times the 3 inside, 3x plus 5, x squared plus x minus 1. Can we factorize that further? Are you serious? Do you mean yes, I'm serious, or like me, yes, I can factorize? You can factorize. Okay, you can factorize. So the discriminant will be b squared minus 4 times a times minus 1. Okay, so it's a positive number greater than 0, so it's 5. Okay, you can factorize, but I can't really factorize by simply sit, so I will use completing square. So 3x plus 5, x squared plus x plus half of b squared, subtract half of b squared, and you still subtract this one. So 3x plus 5, those 3 terms, what you will have is x plus a half squared. Minus a quarter minus 1 is minus 5 over 4. So square root over 2 squared. Okay, so 5 over 4. Finish the bracket. And that will be 3x plus 5. X plus a half plus square root 5 over 2. X plus a half minus square root 5 over 2. Okay, any questions? Yep. Okay, do you want to ask me later when I finish? Okay, next one. Factorize. Okay, when you see this, what do you think of? Anything coming from your mind? Like, what's that looks like? What's the formula? X. Yeah, it's the cube one. Which cube one? Yeah, the minus cube, yes. So it's a cubed minus b cubed, right? Yeah. So what's this one? A minus b, a squared plus ab plus b squared. Do not read from your notes, everyone. You need to memorize it. Okay, you need to memorize this. That's why I tell you this formula is important, because it helps you directly factorize. So that will equals to x cubed minus 3 cubed. Okay, 27 is 3 cubed. So it's x minus 3 x squared plus 3x and plus 9. Can we factorize that? I give you another chance. Can we factorize that? No. Okay, discriminant is 3 squared minus 4 times 1 times 9. I don't want to write it out every time. Yeah? 9 minus 9 times something, it must be smaller than 0. Wait, but like, I know directly this cannot be factorized. Why? Because if you use this formula, a cubed minus b cubed, and this quadratic cannot be factorized for sure. Okay, if you use this formula already, and the quadratic you work out from this formula cannot be factorized for sure. So you can't do anything to that. You don't even need to test it. But like, to be safe, better test it, because you may find something greater than 0, which means you write the equation wrong. Okay, you write the formula wrong. So it shouldn't be factorized if you use this cubic formula. Okay, and we have a similar question here. So it's 2 cubed plus a on 3 cubed. So a cubed plus b cubed is a plus b. A squared minus ab plus b cubed squared. So what I will have is 2 plus a over 3 times 2 squared minus 2 times a over 3 plus a over 3 squared. So what I will have is a third a plus 2, and that gives me 1 on 9a squared minus 2 on 3a and plus 4. I just changed the order. Okay, I just changed the order. And again, that's a quadratic cannot be factorized, because I have used this formula. I have used the cubic formula. So this cannot be factorized. You can test that, but it cannot be factorized for sure. So it's 2 on 3 squared minus 4 times 1 9 times 4. It must be smaller than 0. I really need to do another page, everyone. I don't have much time. I need to complete, but like, this page is really easy. So what this page talking about is solving cubic equations. So what is solving cubic equation? You just make everything to the left, right hand side to be 0, factorize the left hand side, and use non-factor law to solve for that. So now I have that times that times that equals to 0. So you want to have x minus 1 equals to 0, x plus 1 to be 0, or x plus 3 to be 0. So x can equals to 1, or x can be negative 1, or x can be negative 3. I have 3 solutions. I have 3 solutions. After factorize for you, it's really easy to solve. But remember, the right hand side must be 0 in order to use non-factor law. Otherwise, I cannot use the non-factor law. Okay, example 2 is either 2x plus 1 to be 0, or x minus 3 to be 0, or x plus a third to be 0. So x will be negative a half, or x equals to 3, or x equals to minus a third. Okay, I have 3 solutions. I have 3 solutions. Okay, next one is removing the highest common factor. So, what means by removing the highest common factor? Like, can you see there's no constant term, and x is the common factor for all the terms. So that is the easy case. If you don't have the constant, which is really easy to deal with. But my question is, can I divide x on both sides? Can I divide x on both sides now? Yes or no?
Yes.
No. Because x could be 0, right? You don't know what is x. X could be 0. I cannot divide 0 on both sides. I can divide a number, but not 0. So I will factorize it first. Always factorize, okay? So you have x squared plus 2x minus 10. That is 0. Okay, so then you will solve for this. I need to factorize further for this one. So I'll have x squared plus 2x plus 1 minus 1, and you still have the minus 10, that is 0. Then x will be bracket, those 3 terms will be x plus 1 squared minus 11, so root 11 squared, 0. So I have x plus 1 plus root 11, x plus 1 minus root 11, and 0. So what do you have? You have x equals to 0. Can see like x is actually 0. So if you divide x on both sides, you miss one value. Okay, you don't have x to 0 solution. You miss one solution. Or x equals to, that equals to 0 is minus 1 minus root 11. Or you have x equals to, okay, that is minus 1 plus root 11. Okay, 3 solutions. Okay, we have x as common factor as well, so we will take x as common factor. Have 2x squared minus x minus 1. Okay, so we have that. Okay, if you can factorize, that's 1, 2, minus 1 and 1. That gives me minus 2 plus 1 equals to minus 1. So which is correct? Then it's x minus 1 and 2x plus 1 equals to 0. So x will equals to 0, or x will equals to 1, or x will equals to minus 1 on 2. Okay, next question. Next question, like, I have 2 ways to do it, but like I will show you the normal way first. So think about this, that's x cubed cubed equals to minus 8, right? And x will equals to the cube root of minus 8. Then x just equals to minus 2. Okay, that's the normal way how we do it. Or you can factorize it. So it's x cubed plus 2 cubed. So if you factorize the left hand side, you have x plus 2 x squared minus 2x plus 4 equals to 0. This one cannot be factorized, which means no solution. Okay, remember, like if you cannot factorize, which means there's no x-intercept and I can't find the solution. No solution for that. So again, you will only have x plus 2 equals to 0, then x equals to minus 2. Okay, it's actually two ways to do this. But like obviously the top way is much easier. Okay, the top method is much easier. But the bottom one will be follow whatever we learned recently is factorize. Okay, factorize and use non-factor law to solve. But for the second part, if you use non-factor law, it's not going to be 0. Okay, you can't solve out x equals to 0. So you have no solution for that quadratic. You only have x equals to minus 2. Okay, for this one will be 10 to the power of 3 equals to 1 over x to the power of 3. Then 10 will equals to 1 over x. Then 10x equals to 1 and x equals to 1 on 10. Or you can use 1000, which is 10 cubed minus 1 on x cubed equals to 0. Then you will have 10 minus 1 on x bracket 10 squared plus 10 times 1 on x plus 1 on x squared equals to 0. Then is that 100 plus 10 on x plus 1 on x squared equals to 0. Again, no solution for that because it's using that formula to solve. Okay, because you use the cubic formula, which means the quadratic cannot be factorized for sure and cannot like solve. So you will have 10 minus 1x equals to 0, 10 equals to 1x, then x equals to 1 on 10. So again, the first method will be easier. It will be correct, okay, it will be correct. But the second method is how you can factorize and solve for answers. And the last method to, like the special method to solve for it will be the grouping method. But the grouping method, no one really tell you that's a grouping method. You need to find it out by yourself. You need to see, okay, I can grouping them. Okay, I can grouping them. So let's try to group them for the first two and the last two. Let's see if anything will be different. So I will have x squared and then that's x plus 4 minus 3 will be the common factor and you have x plus 4. That equals to 0. Then you have x plus 4 and x plus 4. So you have x plus 4 as the common factor. Then you have x squared minus 3. That equals to 0. So x plus 4 is one factor already. And for this one, you have x plus root 3 and x minus root 3. And equals to 0. So your x will be minus 4 or x will be plus minus of root 3. Yeah, plus minus of root 3. Or you can group those two. Okay, you can group this one and this one together, and the other two together. That will give you the same result. Okay, that will give you the same result. Grouping can always find two ways to group them, okay, not only one way. Okay, the last one. Last one. Again, I will still try the first two and the last two. So I'll take x squared, so it's x minus a. I'll go minus 11 here, and I will have x minus a. Then x minus a is the common factor. Have x squared minus 11 equals to 0. Then you have x minus a, x plus root 11, and x minus root 11, because you can say that's x squared minus root 11 squared. Okay, you can do that. So x will equals to a, or x will equals to plus minus root 11. Okay, so 1, 2, 3, that 3 is the special way to factorize. Okay, it's the special way to factorize. Your homework, okay, your homework in weekend will be, okay, page 59, okay, page 59, page 61, page 62, factorize all of that. 61, 62, and 59. Factorize the equation.